In the previous tutorial, /posts/Python tutorial testing / we learned about testing with PyTest. Now let's learn about async/await, Python's way to run multiple tasks at the same time without threads. Let's break it down. How async works. Simple explanation. Think of a restaurant with one waiter. The waiter takes an order from table 1, then waits at the kitchen until the food is ready. Only then does the waiter go to table 2. Async def and await. An async def function is a coroutine. You cannot call it like a normal function. You must await it or pass it to asyncio.run. Inside an async function, you can await other async functions. Important, you can only use await inside an async def function. Using it in a regular function causes a syntax error. Asyncio.run. The entry point asyncio.run is how you start async code from regular, synchronous, Python. Rules for asyncio.run. Call it once at the top level of your program. Do not call it inside another async function. Use await instead. It creates an event loop, runs the coroutine, and cleans up. Asyncio.gather. Run tasks concurrently. Asyncio.gather runs multiple coroutines at the same time and collects all the results. Output. All 4 items are processed at the same time. The total time is 0.1 seconds, not 0.4 seconds. Note, asyncio.gather returns results in the same order as the input, even if tasks finish in different order. Asyncio.create_task. Fire and collect later. Asyncio.create_task starts a task immediately without waiting for it. You collect the result later. When to use create_task versus gather. Use gather. When you have a list of tasks and want all results at once, use create_task. When you want to start a task and do other work before collecting the result. Error handling in async code. Try/except in async functions. Error handling works the same way as in sync code. Gather with return_exceptions by default. Asyncio.gather stops on the first error. Use return_exceptions equals true to collect all results including errors. Output. This is useful when you want to continue even if some tasks fail. Async for. Async iterators. Sometimes you need to iterate over data that arrives asynchronously, like streaming from an API or reading from a database cursor. Use async for. An async iterator implements __, iter __, and a next __. The async versions of __, iter __, and next __. You will encounter async iterators when working with database cursors, streaming HTTP responses, and message queues. Async with. Async context managers. Some resources need async setup and cleanup. Use async with for those. Output. This is exactly like the regular with statement from tutorial 15 /posts/Python tutorial context managers / but with async support. You will see async with everywhere in async database libraries, HTTP client sessions, and file operations. Timeouts with asyncio.wait_for. What if a task takes too long? Use asyncio.wait_for to set a timeout. Always set timeouts on network operations. Without a timeout, a stuck connection can hang your entire program. Rate limiting with semaphore. When making many concurrent requests, you might overwhelm a server. Use asyncio semaphore to limit how many tasks run at the same time. The semaphore acts like a bouncer at a club. Only 3 tasks can enter the fetch section at a time. When one leaves, the next one enters. Async HTTP with HTTPX in real projects. You will use the HTTPX library for async HTTP requests. Here is a preview. We will cover HTTPX in detail in tutorial 19 /posts/Python tutorial http/. The HTTPX.async client is an async context manager. Uses async with. It manages connection pooling and cleanup automatically.